All right, this lesson here is on function notation and finding meaning from function notation. So I went back and I drew some examples from a textbook that I no longer issue to you, but it's one that I pull lessons from. And what it is, it's really good for examples. So does anybody recognize this sport here? It's a winter Olympic sport. It looks like the bobsled. Okay. But it's different from the bobsled. And in a bobsled, I think you're kind of enclosed, at least in the forward part, and you kind of get inside. Here, there's nothing. You're just laying on a sled, and you're going straight down, and you have to maneuver and guide yourself by using only subtle movements of your body. So it's actually called luge. Luge. It's very, very serious. I remember several years ago, I don't know if it's been 8 years ago or 12 years ago, in a practice session, because they're screaming down the hill at 50, 60, 70 miles an hour, depending. And when they hit the curves, it's up to them to kind of lean with their bodies or twist their feet this way or twist their legs that way or change the angle. It's very, very subtle movements, and you have to kind of drive yourself. So you can drive yourself higher in the lane or lower in the lane. And the one who gets through, of course, in the fastest time wins the event, wins the gold medal. The thing about luge is there was a guy that got killed, actually, in a training session. He come down. For some reason, he hit into a barrier, and immediately the cameras went off. It was during a practice session, so he wasn't fully on, but obviously the security cameras did pick it up. So it was a video. You don't actually, you see him crash, but you don't necessarily know at that time that but he didn't survive it because he was going so fast. So it is very serious, but this is an Olympic sport. Okay, the purpose of kind of showing you that it's a tie-in is to say that, hey, we have this data that was collected. Now, obviously, if it's a luge, what you do is you're running down, and you kind of grab the snow and the ice, and you take off, and then you assume this position. And obviously, he's feet first, right? So he's feet first. He's feet first, and he's kind of looking down like this. His head is protected, and what he's trying to do is he's trying to guide. So he knows where the turns are coming up, and when he has to bank, and when he doesn't have to bank. But everything that's giving him speed is a vertical drop, right? So you're going to start somewhere up on a hill, and it might take a while, but you're going to come down the hill gradually, and you have to do a number of turns. And if you know anything about physics, you know that if you're in a turn, it makes you feel like you're flying. It's one of the famous tricks of people who design roller coasters. Because when you go to climb to the tallest hill, when you come down at the bottom of that hill, you're going the fastest that you'll ever go during most any part of the ride after that. Okay? But toward the end of the ride, they trick your body into still feeling this sensation of, yeah. Because they'll send you into lots of loops and turns and corkscrew type things. They're trying to change your direction. So what happens is a 10-meter vertical drop could be run in 143 seconds. Okay? 10-meter vertical drop means I'm going to go from here. It's basically like 10 yards. Okay? That's not a huge vertical drop, so it's obviously going to take a long time if he's twisting and turning through a very slight drop. What if he drops, 90 meters? Okay? If he can do it a lot faster, 48 seconds. Does everybody get what we're saying? Now, the track is going to wind its way down around it, but you're still coming from here to here. So the longer the drop, the shorter the time. It's kind of an inverse function, isn't it? The longer and longer or higher and higher and higher that you go for the drop, the shorter and shorter the time it takes to come down the hill. Does everybody kind of know what we're saying? All right, we've got some data collected. Let's just see what we can do with the data. All right, I goofed when I printed your notes. I goofed. You have the data, and you have the graph, but I forgot, or for some reason wasn't thinking, you do not have these A, B, C, D, E questions. What I'm going to ask you to do is, I don't want you to copy the whole question, but I do want you to copy the part that I'm going to highlight so that you can have, and you have the margin, don't you? You have the margin. Okay. What we want to do is we want to talk about vertical drops. In this case, is a function of the run time, or the run time is a function of the vertical drop. What I do first is I'm going to figure out what the drop is, and then I'm going to be able to calculate how much time. So when you enter the event, you know what the vertical drop is already. So that makes it the first thing you know. You're going to actually time how many seconds it takes you to come down. So Vertical drop versus run time. Okay. Use the information in the table and graph relating downhill run times to the vertical drop of the luge to answer the following questions. Now, notice when it says, how is the fact F parentheses 50 equals 64? How is that shown on the graph? Okay. All right. What's on the y-axis? Run time. Okay, today is about making meaning of it. So f of x is kind of like what? The old y, isn't it? So that's why I'm on the vertical axis. So what's on the vertical axis is run time. So we could say t equals, or t parentheses v is how we could think of it. The time is a function of what? What the vertical drop is. Your time depends on how high the vertical drop is coming down. Let me say that one more time. Meaning-wise for this graph, my time depends on what? The vertical drop. If I'm only dropping 10 meters, the time is going to be longer. If I'm dropping 80 meters or 90 meters or 100 meters, the drop is going to take a lot less and less and less time. So the time it takes is a function of vertical drop. You could almost put it like that. All right. How is the fact that f of 50 equals 64? How is that shown on the graph?
T equals 50.
Okay. What's inside here is what?
The vertical drop.
Vertical drop. Okay. Do I have a vertical drop of 50?
Yes.
All right. Does it give me a answer of 64?
Yes.
All right. So what's in the parentheses is vertical drop. What's out of the parentheses is the what?
Time.
Time. Okay. So somewhere on the side of your paper, put part A, 50, write this down. Pick your pencil up, write this down here, right there. F parentheses 50 equals 64. Write that on the margin. Draw an arrow and say 50 is the vertical drop, 64 is the time. It's making meaning of something, okay? It's making meaning. It's pausing to think, what does this data mean? Because we've spent, the past 2.5 days or whatever, little bits and parts of a couple of days, and in between we had a little day or two off for fall break, trying to understand how to use function notation. Now we're trying to make meaning of function notation. What y values satisfies the equation, some y value equals the function at 40? What's in the parentheses again?
Time. Vertical drop.
Vertical drop. So what would the y answer be?
Time.
Write this down on your paper. Part B. Just write down the part that's in yellow. Y equals F parentheses 40. So what does Y equal? How'd you get that? He says Y equals 71. Is he right? Because this is a vertical drop, so I'm going to go to a vertical drop of 70. Whoops, sorry, 40. I was looking at the wrong one. I was thinking of the answer. And then the answer is what? Does everybody see how I got that? What I'm doing is I'm taking notice of what the parentheses is and what the equals is. Does everybody see what we're doing? Okay. What about part C? Write this on your paper. This is where I wish I had not missed out. Write down 51 equals F parentheses X. This time, make meaning from it. This time I don't have the number in parentheses, I have the number on the other side of the equals. What do you have this time? You've got the Y answer, or you've got the time. Can I figure out what vertical drop gave me that time? Okay. So a time of 51 seconds must have had a vertical drop of what? 80. About 80 meters. So X is equal to 80. Do you understand how we're getting these answers? Is this making any sense at all? I am trying to make you notice what the parentheses means and notice what the equals means. Okay, next one. Write this down on your paper. Y equals F parentheses 10. F parentheses 10. Just write that part down. What value of y satisfies equal? Now what did I give you? I gave you the parentheses. I gave you the what? I gave you the vertical drop. What are you looking for?
One time.
You're looking for the time. So what's the vertical drop of 10?
43.
So the time is, or the y answer is 110 seconds.
Could it all be this easy?
It's just understanding meaning. Last one, write this down. 45 equals f of x.
It would be 110.
Oh, did I look? Oh, yeah, you're right. 143. Thank you. There we go. Let's go back to E. 45 equals f of x. 45. I gave you 45. What did I give you? Did I give you a vertical drop number or a time number? I gave you a time. So this right here is a time number. So I'm asking you, what vertical drop gave me that time? Okay, so if I come down here to this side, 100. Okay. Not too bad, is it? All we're doing is looking for information in a table, but you got to look at it in the proper order. You got to know what you're looking at. All right, that's it with that first one. It says making meaning. Now, do y'all have an example at the bottom? And I think I did copy the questions for this one. Okay, there's A, B, C, D, E questions. Okay. Bouncing balls. Gravity has the same effect on all objects, whether it's an athlete on an ice-covered luge course or a ball dropped from a tall building. However, gravity brings luge objects down to stay while it has to bring bouncing balls down again and again and again. The following graph shows how the height of one type of bouncing ball changes over time when it's dropped on a hard surface. Can anybody tell me how high we started on this dropping ball? Okay, so everybody see that this would have been the what? That would have been the starting point. So we started at a height of 10. Okay, height is on the what? Y-axis, or now we call it the what? F of x axis. Is everybody good? What's being graphed on the x-axis? Time. So it's just about paying attention to your axis and understanding what we're talking about. It's common to choose letter names for functions and variables that indicate the quantities involved. So that's why this time they're using H parentheses T. What does that mean? Height, and let's read this. Height is a function of what? Time. Height is a function of time. I cannot tell you how high the ball is until you tell me how long it's been bouncing. Okay? So I'm going to measure out the time in seconds, and then we're going to figure out what height it was. All right, let's use the graph above. Same kind of questions. I'm going to pause right now and let you take a shot at answering A through E. Look around. You give it an answer. You ask around and see how they do. It's take about a minute, no more than that. Can you do this one without a graph? I mean, with a table, without a table, can you do it on a graph? Okay. What did I give you? What information is expressed by H0 equals 10? Okay, I want you to read this letter by word, letter by number by number by number. What do you think H stands for? Height. All right. What does 0 in parentheses stand for? At 0 what? Okay. Height at 0 seconds. What is an equals usually replaced with what little word? Is. And what's 10 represent? 10 feet. Did I take it step by step? H is the letter what? Height. 0 is what? Seconds. What's an equals? Is. And then 10 is a feet number. Does everybody see what I did? I just wrote it out in words what that little phrase meant. Okay, it's making meaning. All right, you can tell me what B is. What are we looking for? What did it give me? Height at 4. Height at what? 4 feet or 4 seconds? 4 seconds. What's in parentheses is x, right? So it's height at 4 seconds. What is the height at 4 seconds? Height would be what? Height at 4 seconds equals 5 feet. Does everybody see what I just did there? Okay. I'm making meaning. All right, what does this say? Let's read this one now. Let's read this. What does H stand for? What word? Height. All right. T is not, there is not a number there. So height at what? At what time? What is equal usually replaced with a word? Is. And then what's 8? Is that a feet number or a time number? A feet number or a seconds number? Feet. Because that's on this axis, right? What value satisfy this equation? Height at what time is 8 feet?
1.5.
All right, so 8 feet. This time it's giving me this number, so I'm going to go to 8. It was at 8 feet here. It was at 8 feet 2 different times. It was dropping, it fell through 8 feet mark, and then it dropped and hit the floor and bounced back up, and then it bounced back up when? How many times was this ball exactly 8 feet off the ground?
0.5.
I agree. Is it quite 0.5? Okay, this looks like that's at 0.5 is the line. I can see a faint line. Can y'all see a faint line? It looks to me like it's just behind the 0.5 line. 0.4. All right. So T is approximately 0.4 seconds, and exactly, that looks pretty much exactly at 1.5. Do y'all see that?
Yep.
All right. Does everybody know how to read this? Take it right letter by letter and just ask yourself, what does these things stand for? What is the value of H parenthesis 1? Height at 1 second. Okay. What is the value? You explained it to me. What is the value? Height at 1 second. Okay. It looks like it comes up here. Oops. Right here. 4 feet. Mine's pretty messy. What values of T satisfy the equation? Yes. When is the height what? What are we talking about? The height at what time equals is, and then 0. Does everybody understand what that said? H is height. This is at what time. The equals is the is, and the 0 is a feet number. When was this thing at 0 feet?
10.
No, when was it at 0 feet?
Oh, 7.
I think it's going to be like a bunch of times.
0.8, 2.2, 3.2.
Ah, I'm hearing some numbers now. Looks like it fell right here.
That's a 0.5.
No, it's not. 0.5 is back here. About 0.8, 0.7, 0.9. You said any of those?
I think that's good.
Well, we have to say, I'm going to put the little squiggly equals. What does little squiggly equals mean? Approximately equal to. So about 0.8 seconds. What else? All right, then it went up and it came back down here. About 2.2. I agree with that. Approximately 2.2 seconds. What'd you say? Ooh, 3.45. That's pretty close. 3.4 seconds. And then what? 4.6. Approximately 4.6. We're allowing ourselves, we're indicating right here with these little squigglies that we understand that it's not maybe a perfect answer. All right. Do you understand what we're trying to do with this lesson? We're trying to make you pay attention to what an actual example would be. Okay. Let's turn to the back. He left a little early, I think. Function as tables. Same kind of thing. These are going to brush through, and here we go. What do you think H stands for? Height. The function H parentheses A represents the average height of boys that are what? years old. At the top, write this down. Height is a function of what? Of age. I would say that's what the 8 or the H and the A both stand for, is height and age. Everybody good?
Yeah.
Tell me what H parentheses 7 means. Explain what each means. That's the H stands for height at, what does 7 mean? 7 years. Height at 7 years. Now, go ahead and tell me what the answer is. At 7 years, 49 inches. Are we reading it straight like H stands for what? Height. Parentheses 7 stands for what? 7 years equals 49. What does H parentheses 1.5 mean? Height at 1.5 years old. I don't see 1.5 up there. Okay. But 18 months is the same thing as 1.5 years. So the answer would equal what? 34 inches. Everybody good? Okay. What's C? Height at 11 years old, which is 57 inches. What does D stand for? Height at 12 and a half. I don't have that in my table, but I can probably interpolate or guess what a reasonable answer is. So we'll have to say this time our squiggle lines. Does everybody understand why it's squiggle lines? Because we don't have an exact answer to say. We're saying approximately what? It depends on how fast they grow. Maybe they grow like 3/4 of an inch, and then they grow an inch and a quarter. It may not be exact, but we can say approximately 60. All right, number 2. Calculate the value of A that makes the equation true. Explain what each means. When I say explain what each means, I want you to go letter by letter, equals by equals, and number by number, and tell me what each part represents. What does H represent? Height. What does parenthesis A represent? Now, I don't have a number in there, right? So I'm going to say height at what age? Because I'm looking for the age, right? What do I use for equals? Is, and then what's on the other side of the equals? 61. It's almost like I could take that and make it a question out of it, right? Height at what age is 61. It's almost like I'm just changing these from math letters into written words. Do you have an answer for me? 13 years. So the age equals 13 years. All right. Let's do B, C, and D, and we'll go to lunch. Height at what age is 36? 2. 2 years. All right. Height at what age is 53? 9. All right. Height at what age is 45? All right. So we'll do the squiggles. Approximately what? 4.5 years. Lunchtime.
you doing, Tasha? My arm still, I say you still. Short? Yeah. Tall? Hard on. Bro, she don't let you look her for it. That's tricky.
I'm trying to go to my friend.
Not compared to
Whiskey River.
To a magical unknown land.
dead. Rock line. Give it to
The rainbow will come out of the storm.
You never heard that song, Bruce? You heard it? Heard my witness?
The rainbow comes out of the storm. Yeah, this is makes us go away.
Do it. Oh my God! Where'd I go? Man, it's a black hole. Oh, kidding.
I dressed up really cute for it. I wear bucket shoes.
You wear some dang Pikachu. You gonna be after class.
Okay, cool.
Hey, let's work.
Your hairline ain't straight. Your hairline ain't straight, son.
Swear to God.
Like it.
Wait.
Oh! I'll never own you. It's not on you. It's on your horn. That is not part of it. If you took that off, that is not part of it. No, it's not that. It's a hickey. It's not even that guy. He got some nice feet. I can't do it there. Silence you back. Hey, Brian. I saw Lola in there. I had it all. You know what? I hear a fly.
Good, I hope
You
so.
hear that fly? Brandon, you hear that fly? He's dumb. Yeah. That's a fly on you.
Yeah, the flies are gonna disappear.
Brandon, fly just hit me. Okay. Yeah. He likes it. He likes it. Wait, who you talking to? Who you talking about? I didn't say you. Who you talking to? Hey, what's your hat say, love? They're only little. I know you ain't trying to back here. Don't do that. Don't do that. You might get small head. Stop. No, don't even rear back. Just don't rear back. Don't rear back.
No, it
I see my heart. Did he just laugh at you? Shoot team.
I'll take you, beat him.
Okay, then
Oh,
you
it's
what?
like-
What?
That quesadilla,
Oh, shit. That guy was in there earlier.
Did your father quesadilla doing stuff with girls? Did your father?
Yes.
Hey.
Oh, he did. I know this girl. Are you sure? I asked him, I was like, sure?
What's the dude's name? I don't know who you're talking about.
I was sure.
Where you go? What's the dude's name?
Positive. Positive. Why don't you give it a good friend?
Why don't you go ahead and start fixing it? Alright, let's see if we can finish this. Hey, back in your seat. This is good. I was talking to Miss Patterson. I know. I'm not done.
Is it still recording?